So this is 3.7.1. So we have two sections just to cover 3.7. Now, if you look in more, there's actually 3 sections for 3.7, but the third section is a written assignment that you have to do. So there are no new notes in 3.7.3. It's just instructions for your written assignment. Okay. So we're going over 3.7.1 and 3.7.2 with the understanding that 3.7.3 is a thing. It does exist, but there are no new notes in it. It's just a written assignment that you guys have to do. So you'll see all of the instructions are in there. You have to fill out some, like you have to either print or handwrite answers to, I think it's 5 questions on rational functions, and then like upload your solutions. Okay. So here, if we are looking at a rational function is any function that is a fraction and where there are variables in the denominators. So this is a perfect example of a rational function. When we're talking about the domain of a rational function, well, anytime we have a fraction, we have to be concerned about zeros in the denominator. So the domain of a rational is going to be all real numbers except whatever values would make the denominator 0. So in order to find the domain of a rational function, we're going to set the denominator equal to 0 and try to figure out what those values are. And then, well, 4 times a negative 9 is a negative 36. Are there 2 numbers that multiply to negative 36 and add to 1? I feel like no, but let's check. 36, 1 and 36. 2 and 18, 3 and 12, 4 and 9, 5 doesn't go in, 6 and 6, but that would not give me 1. Okay, so there are no 2 numbers that multiply to a negative 36 and add to 1. So I'm going to have to use the quadratic formula. So W equals a negative 1 plus or minus the square root of 1 squared minus 4 times negative 9 over 2 times 4. Let's grab my calculator. So 1 squared minus 4 times negative 9. 145. Plus or minus the square root of 145 over 8. They're asking me for rounded to 3 decimal places. So I'm going to split this, negative 1 plus the square root of 145 over 8. And negative 1 minus the square root of 145 over 8. So negative 1 plus the square root of 145. We want that to be out here. There we go. Over 8. 1.380. And then second and enter to pull up the last thing that you typed in, because the only difference here is that I want a minus right there. Negative 1.63. Okay, so in set notation, we would say W is a real number and W is not either one of these 2.
Hello?
Thank you. Bless you. Bless you. And then, that got really messy. Let's fix it. There we go. So W is a real number and W cannot be either one of these 2, because if I plugged either one of these 2 in, I would get 0 in the denominator. No good. Any other number I can plug in. There's no other number that would give me 0 in the denominator besides those 2. A note that proper set notation, you have these written in numerical order, which is why I put the negative 1.63 before the 1.38. Okay. And now interval notation for these would be everything to the left of negative 1.63. I'm going to write it down here because I'm afraid that I'm going to go like above or outside that box and it's going to be hard to read. So negative infinity, everything to the left of negative 1.63. Everything in between negative 1.63 and 1.38. And everything to the right of 1.38. Okay. So that's everything to the left of negative 1.63, everything in between those two, and everything to the right of 1.38. Notice that this is all parentheses because we are not including the negative 1.63 and the 1.38. Okay. All right. So here, we're going to do the same thing, only we have this polynomial. And we want to say, when does that equal 0? Well, when we talked about polynomials, I said that if you need to solve a polynomial, the first thing that you should always do is graph it. I'll try to get this so that you can see the question and my calculator. Okay, so y equals, clear whatever this is, 8x to the 4th minus 32x to the 3rd plus 25x squared plus 52x minus 60. 8x to the 4th minus 34, not 32. Ha. 34x to the 3rd, 25x squared, 52x minus 60. Okay. So we'll graph this. Oh, I accidentally deleted my square. Let's fix it. Yeah, did your baby go make you happy?
Baby cup.
Yep, that's your baby.
Oh
no, baby. This one's gross. All right, I have 2. So I'm going to zoom in around that because I think that 2 was a repeating root. I think it was a bounce. So let's see.
Oh no, she's sleeping.
She's sleeping?
Okay.
I wanted negative 5. Oop, you can't come up right now, sweet baby. You can't come up right now, sweet baby. Yep, that is a repeating root. So every time we have a bounce, remember, that means that we had a multiplicity of 2. So that means that we do have 2 as a root, and 2 happens twice. I know, honey, I know. Come here.
Yeah.
Brian, are you still here? Can you take her for a few minutes? Why is she in here with me if you're still here? No, I'd rather you interrupt me than she's sitting here. She's sitting here screaming at me. You're here. You don't need to do anything. You gonna teach the class? Come on. You're gonna go hang out with Daddy for a few minutes. Where's Daddy? Okay. So the fact that that 2 repeats means that I can take it out twice, because I know that when it bounces like that, that the x plus 2 or x minus 2, because it was a positive 2, x minus 2 happens twice. So remember, this is multiply and then add. Multiply and then add, multiply, and then add, multiply, and then add. And then, like I said, we can do that 2 a second time. 16, add, multiply, add, multiply, add. Okay. So here, if we started at a to the 4th, then this would be a to the 3rd, and this would be a squared. So what I have now is 8a squared minus 2a minus 15. So are there two numbers? What is 8 times 15? 120. Are there two numbers that multiply to 120, negative 120, and add to a negative 2? Yes, so this one does factor. 8a squared minus 12a plus 10a minus 15, right? A negative 12 and a 10 will multiply to 120 and add to negative 2. So 8a squared and 12a have a 4a in common. A 10a and a 15 have a 5 in common. And then these have a 2a minus 3 in common. So then if 2a minus 3 equals 0, then 2a equals 3 and a equals 3 halves. Call that 1.5 because they're asking for decimals. If 4a plus 5 equals 0, then 4a equals negative 5 and a equals negative 5/4, which should be negative 1.25. So I want to look back at my graph real quick and make sure that those make sense given the graph that I have. Yeah, I mean, this one right here looks like it's just past negative 1, so that would be negative 1.25. And this one in here looks like it is halfway between 1 and 2, so that would be the 1.5. Okay, good. I always like to double check that, make sure that what I got at the end matches the graph that I was looking at. Now, so here we have a is a real number and it cannot be negative 1.25, 1.5, or 2. Another note about set notation is I know that I had the 2 repeats, but I don't write repeats. Okay. So then in interval notation, I would say, and again, I'm going to write it down here because I write too big to fit in that box for interval notation. That would be all of the numbers to the left of negative 1.25, in between negative 1.25 and 1.5, in between 1.5 and 2, and to the right of 2.
Want to go see Adria? You see babies?
Okay.
Come here.
All right. So draw the horizontal asymptote and write the equation for the horizontal asymptote. So when we're talking about horizontal asymptotes, we have 3 scenarios. Your first scenario is if you have a bigger degree on top. And in that case, you would have no horizontal asymptote. Your second degree would be if you had your second scenario would be if you had the same degree top and bottom. And so in that case, you would use the leading coefficients. And your third case would be if you had a bigger degree on the bottom. And in that case, you would use y equals 0. So here we have a first degree on both the top and the bottom, which means that I'm going to use the leading coefficients. So here there's no leading coefficient on the bottom, which means 1, So my horizontal asymptote would be the leading coefficient on the top over the leading coefficient on the bottom. So it would be y equals -2. And so then they want me to actually draw that line in here. Okay. I want to look up what's in these drop-down boxes real quick, because I want to make sure that I'm telling you the right thing. Because this is another situation just like the one that we just did. But again, I just want to make sure that I'm saying the right words for you here. Functions. Here we go. Close. That's the problem I just did. Here we go. Found it. Okay, so they're saying that my options here would be no horizontal asymptote, a horizontal asymptote at y equals 0, or a horizontal asymptote at y equals 1. Those are going to be my three options here. Okay, so we just said if the degree is the same top and bottom, you use the leading coefficients. So this would be 1 over 1. So this would be my horizontal asymptote at y equals 1. We just said that if you have a bigger degree on the top, that you have no horizontal asymptote. So this would be the no horizontal asymptote. And then we said if you have a bigger degree on the bottom, your horizontal asymptote is at y equals 0. Okay. All right. So here we go. Another horizontal asymptote question. So horizontal asymptotes in rational functions, they describe the end behavior to us. So here we have a bigger degree on the top, right? Because if we wrote this in standard form, I have a degree of 10 on the top, a degree of 4 on the bottom. So a bigger degree on the top means that we don't have a horizontal asymptote. So then I need to figure out what's going on the left and the right. Same top and bottom. Same. Here we go. So if this was the same top and bottom, then you would just be approaching 0. Let's go back to that last one. So if this was the same top and bottom, you would be approaching whatever your leading coefficient was. So for example, if you had we'll use this one. So if you had this, then on both the left and the right, as your x was going toward infinity or negative infinity, your y would be going toward this -2. You see it? So if I was filling these boxes in for this problem, I would say as x goes toward infinity, y goes toward -2. As x goes toward negative infinity, y also goes toward -2. So that's same degree top and bottom. If you have a bigger degree on the bottom and your horizontal asymptote is y equals 0, then both of these are 0. Now, if you have a bigger degree on the top, then we need to start looking at the signs here. So here, first of all, bigger degree on the top means there is no horizontal asymptote. So this is d any. Now, if we have a negative leading coefficient on the top and a negative leading coefficient on the bottom, that means that overall we have a positive leading coefficient. Here we go. Again, I'm just double checking and being 100% sure that I'm telling you guys the right thing. Yes. Okay. So then you use the same general rules that you do for polynomials. So if you have a positive leading coefficient, then you're going to wind up down on one side, up on the other. And if you have a negative leading coefficient, then you're going to wind up down and down. Or was it up and down? Let me double check. This was the same. I feel like this was this way. It was this way. Ugh. Yeah, it was that way. Okay. So a positive leading coefficient, and again, that's overall. So here I wind up with a negative over a negative, which becomes positive. So here, as on the right side, as x approaches positive infinity, h of x will approach positive infinity. And on the left side, as x approaches negative infinity, h of x will approach negative infinity. And then if you wind up with a negative over a positive or a positive over a negative, then these two switch places. Okay. So having said all of that, let's take a look at the next. First thing I need to do here is figure out degree top and bottom. So remember, in factored form, to figure out the degree, we add the degrees. So the degree of the numerator would be 3, 7, 6, 8, 24. And the degree of the denominator, 5, 7, 5, 4, 21. So again, I have a bigger degree on the top and a negative leading coefficient this time. So this time I'm going to say as t approaches infinity, p of t approaches negative infinity. And as t approaches negative infinity, p of t approaches positive infinity. And then the horizontal asymptote was again d and e because we had a bigger degree on the top. Okay. All right. So then in 3.72, we have vertical asymptotes. So vertical asymptotes happen at undefined values. They're one of two possibilities when you have an undefined value. So here we know that a can't be 3, right? Because 3 minus 3 is 0. So that means we have a vertical asymptote at a equals 3. And it's right there in the name, vertical asymptote. So it's a vertical line. Okay. All right. Anytime we're dealing with a rational function, the first thing that we should do, if we can, is reduce. So here, I'm going to cross out these 7r minus 4s. And I'm going to make a note here that anytime you cancel a factor like that, you have a hole. So anytime you cancel a factor, you have a hole at that canceled factor. So it says has a hole at the ordered pair. I know I'm jumping to C, but that's because I found the hole first. So To figure out the y value for that home, you plug your whatever your x value is into the reduced version. Because if I plug 4/7 in before I cancel, then I'm going to wind up with 0 in the denominator and 0 in the numerator. No good. But if we plug 4/7 in after the reduced fraction, -7 times 4/7 minus 5 to the third, 4/7 minus 6. Oops, I put a 9. And then divide that by 5 times 4/7 plus 7 to the third. 4/7 minus 8. So that would be my y value. They want decimals. So what was my x value? 0.571, comma, -0.556. Okay. So again, I know that was part C, but I always do that first because I don't want to forget that I canceled that factor. Are you leaving?
Yeah, I was gonna say, she's got Adriel out there. Do you want her to stay with?
She's fine out there for now.
Okay.
Okay. So, and that should always be first. So you should always reduce first. Okay. Now, my r-intercepts are going to be where the values where my numerator equals 0. So for my r-intercepts, I'm going to say, where does -7r minus 5 equal 0? And where does r minus 6 equal 0? So that's going to be -7r equals 5 and r equals -5/7. But again, they want. So that's -0.714. And r equals 6. So this is where the reason why by the way I deal with the holes first, because if you would include this in your r-intercepts, you'd be wrong. So you should always be reducing first, and if you can reduce, take care of whatever that hole is first, and then everything else after that should be done to your reduced rational. So my r-intercepts would be at -0.7140 and 60. Okay. My vertical asymptotes are going to happen at the places where the denominator equals 0. But again, that's going to be after we cancel, because if you included this in your vertical intercepts, you would be wrong. So vertical asymptotes at 5r plus 7 equals 0. 5r equals -7, r equals -7/5, which is -1.4, and r minus 8 equals 0, so r equals 8. So -1.4 and 8. And then the h of our intercept is going to be where r equals 0. So I would have, well, if I plug a 0 in here for -7r, that's going to become 0. So I would have -5 to the third, and then same thing here if I make that r, and then a -6 on the top, and then a +5 to the third, and a -8 on the bottom. So -5 to the third times -6. Oops. There we go. Times -6 on the top, and divided by 5 to the third times -8 on the bottom. -0.75. Okay. All right, let's do it again, only this time we are in standard form. So again, we should always be reducing first, always. So the first thing I'm going to do is try to get each one of these numerator and denominator in factored form. I am honestly surprised at how little room I left for myself on this paper. So I'm going to get another piece of paper to do this because it is going to take some room. Okay, because we're going to have to do synthetic division for both the top and the bottom. So I have 5t to the third plus 6t squared minus 29t minus 6. And again, I'm gonna graph this. That's always where I'm starting when I'm looking for zeros or factored form of a polynomial. So 5x to the third plus 6x minus 29x minus 6. Okay, looks like I have a 0 at -2 for sure. Let's double check that on the table. Yep, I have a 0 at -2. So we'll do our synthetic division. And we'll divide out that 2, -2. So then that's going to be a -10, and then we add, and then we multiply. Oh, what did I do? 5, 6, -29, -6, and -4. Did I put it in wrong over here? 5, 6, -29, -6. Oh, that would be a +8, but that still doesn't help. X to the third plus 6x. Oh, look at that. I put it in here wrong. I forgot my squared right there. Okay. I was right for the wrong graph. Okay. So this looks like we have zeros at -3 and 2. See, if you noticed, every time I don't double check it, there is a mistake. That's what I get. So multiply, add, multiply, add. Why am I still not? -3, 5, 6, -29, -6. -15. No, that was right. -15 plus 6, -9. -9 times 3 is 27. Oof, -2, 6, 0. Okay, so P.S. I knew that this was a 0, so I was supposed to get 0 here. So anytime I was looking at these numbers and I was like, hey, that's not going to be 0 here, I knew there was a problem. Okay. And the issue is that first I made a mistake and second I multiplied wrong. So I know that I have another 0 at, we said 2. Yep, 2. So then that's 5, 10, 1, 2, 0. Okay. So if this was t to the third, then this was t squared, and this is just t. So then I also have a 0 at 5t plus 1 equals 0. I think that's 0.2, but. Okay. So I just want to verify that with my graph. Yep, look at that. That definitely is right just to the other side of 0. So -0.2 makes sense. Anyway, in factored form here, I'm going to write it on the next page. So in factored form here, here's what I have so far. I have a 0 at -3, so a factor at t plus 3. I have a 0 at 2, so a factor at t minus 2. And then this 5t minus 1 would be my third factor. Okay. Now, let's do it all again for the bottom. 10 t to the fourth minus 33t to the third minus 13t squared plus 24t plus 4. Okay. I'm going to graph it. 10x to the fourth, 33x to the third. Oop, that should be a minus 33x to the third. Minus 13x to the second plus 24x plus 4. 10x to the fourth minus 33x to the third minus 13x squared plus 24x plus 4. I'm just double checking that against the actual question real quick to make sure I didn't copy it down wrong the first time. 10x to the fourth minus 33x plus 13c plus 13x squared plus 24x plus 4. So, okay. Graph it. So Evelyn, I promise you that when you put these in the calculator, you'll get a 0. I promise you. You're not going to be given questions that you won't get a 0 from the graph. Okay? So we don't have to worry about that what if. So here we have 2 as a 0. And if we look at the graph, you'll see that that is a repeating 0 because it bounces. So that means that I know x equals 2. Remember we talked about this before. That means that I have a factor at t minus 2. And since it bounces, that factor is squared. So I can divide out that 2 twice. I should set up my coefficients. So 10, negative 33, 13, 24, 4. And then we're going to take out that 2. So that's 20, negative 13, negative 26, negative 13 again, negative 26 again, negative 2, negative 4, 0. And then since that repeats, I can take it out again. It's 27, 14, 1. So the only other thing I would recommend, by the way, going back to Evelyn's question about what happens if you put it in the calculator and you don't see any zeros, is that if you have a polynomial like this, if you have one of the 4 terms, I usually will check to see if I can factor it by grouping first. This one, though, doesn't factor by grouping. So I would look for that also. Okay. All right, so what I have now, if this was to the fourth, this is to the third, so this is t squared plus 7t plus 1. So are there 2 numbers that multiply to 10 and add to 7? There are. That would be 5t and 2t. So those 2 have a 5t in common, and that would leave me 2t plus 1. These 2 have a 1 in common, and that would leave me 2t plus 1. So in factored form here, I have 2t plus 1 and 5t plus 1. And then that is going to be tacked onto the fact that I know that I had that t minus 2 root that repeated. Okay. So let's take a look at factored form of this thing once both the numerator, oh, that was a plus 1. and the denominator are factored. So I have t minus 2 squared, 2t plus 1, 5t plus 1. Okay. The first thing that I'm going to do is see if I can reduce. So here, I have a 5t minus 1 that reduces. So I'm going to make a note that I have a whole. Plus 1. So we said that was t equals negative 0.2. And then to find the y value for that whole, I'm going to plug that negative 0.2 in. Should be a t. Right? Oh, it was 2t plus 1. 2t plus 1. I'm missing an open parentheses over here. Your entire numerator and entire denominator need to be inside of their own parentheses if you want to do it all as one thing, or you can find the numerator and then find the denominator and then divide. So then the point for the whole would be negative 0.2 comma 2.121, negative 2.121. Okay. Now I have another factor that cancels. The t minus 2 would cancel with one of these t minus 2s. It would leave a t minus 2 in the denominator, which means this looks like you would have both a whole and a vertical asymptote, but you can't have both at one place, and the vertical asymptote wins. So if you have a factor that cancels and leaves something behind in the denominator, then the vertical asymptote wins. So then here's what I know. I know that I have a t-intercept at negative 3, 0 because of this factor right here. And I know that I have vertical asymptotes at t equals 2 and t equals, that would be negative 1/2 when I set it equal to 0 and solve. Okay, let's fill in. So we have, as a t-intercept, we said negative 3, 0. We said vertical asymptotes at negative 0.5 and 2. A whole at negative 0.2, negative 2.121. And then last but not least, the f of t-intercept. Again, I would plug in 0 for t into my most reduced form. So that would be 3 on the top, right? If I put a 0 there, then all I'm left with is a 3. And on the bottom, it would be a negative 2 times, if I put a 0 in here, then all I'm left with is that 1. So I would have negative 3/2. That one was a long one. Lots going on there. Okay. Write an equation for the function graphed below. Use smallest powers possible. All right. So for the numerator, I use my x-intercepts. So this has an x-intercept at 0 and an x-intercept at 3. So the factor would be x minus 3. And then for the denominator, I use my vertical asymptotes. So this would be x plus 1 and x minus 5. And now I see here that I have a horizontal asymptote at 2. So that means that I had the same degree top and bottom, because if you have a horizontal asymptote anywhere besides 0, then you had to have the same degree top and bottom. So I do have same degree top and bottom. This would be an x squared. This would also be an x squared. But a horizontal asymptote at 2 means that my leading coefficients must reduce to 2 over 1. So that would need a 2 on the top. The other thing that we should do, no, I don't think we can actually, because there's no y-intercept. I usually like to double check that leading coefficient and make sure that it is 2 over 1 and not something like 4 over 2, but there are no other good points here. If you have a good y-intercept, then you should plug that in and make sure that your leading coefficient works out right, which we don't. So I'm going to go with it. K of x. Okay. Write an equation for the rational function k with, okay, a vertical asymptote at x minus 2 and x equals -2 and x equals -1 would mean x plus 2 and x minus 1 in the denominator. X-intercepts at -5, 0, and 5, 0 would mean x plus 5 and x minus 5 in the numerator. And then a horizontal asymptote at 4 would mean that your leading coefficients would need to reduce to 4 over 1. So just put a 4 there. Okay. Oh, that's everything. Okay. So I'm going to apologize ahead of time because you guys have a lot this week. I'm going to double check and see if I can bump something back because I think I may have overloaded you this week. So let me start. Take a look at it and see if there's anything that we can push back because, like I said, I think you have too much. Like when I made the schedule, I didn't realize how much you would have due this week.